Hi guys, welcome. I'm Mary. I'm the Professional Development Manager here at the Perot Museum, and welcome to today's live learn on spa science. Mother's Day is coming up in just about a week on May the 11th, and I was really inspired by all of the gifts that we give our mothers, but particularly the bath gifts. So a lot of times for Mother's Day, kids will get their moms things like Epsom salts or bubble baths or even bath bombs. So today we are going to talk about the science behind all of these different products. I'm going to show you some recipes on how you can make your own and give you some ideas on how you can use that in your class for an inquiry activity. So the first item that we're going to start with today are the Epsom salts, and that's in this jar right here. And so we're going to create our own Epsom salts and talk a little bit about what science is behind this and some of the myths and truths to this particular product. So you may be asking yourself, what are Epsom salts? Well, they are a salt because of their chemical structure. However, they're very different from the salt that you would put on your French fries, for example, which is sodium chloride. So Epsom salts are a salt that is made up of magnesium and sulfate, and when they're mixed together in water, they separate into those two different compounds. Epsom comes from a city in England where you actually find these salts naturally in the springs that occur in the town. There's a lot of claims that have been made for Epsom salt on things that it can do. So some people use Epsom salts, and this is just how you would find it in the store. But some people use Epsom salts in their garden to help grow bigger tomatoes or get a higher yield, so you can grow a lot more flowers, according to the tales about Epsom salts. You can use them to help remove splinters by making a paste. We find them in a lot of beauty products as exfoliants to help remove a layer of dead skin. They have been claimed to help treat sunburn. And one of the biggest claims that we see about Epsom salts is that they are used to help soothe muscle aches and relax tired and sore muscles. So the question as scientists that we have to ask is, does that really work? Do Epsom salts really help to relieve sore muscles and help relax your body? Well, the truth is that we don't have any definitive scientific proof that that happens. There are no peer-reviewed studies about Epsom salts reducing muscle soreness. And the one study that was done showed that the Epsom product, the magnesium sulfate that we find in Epsom salts, when applied as a lotion to the skin over and over, did not change anything about the magnesium levels inside the body. Now, the whole thing with the Epsom salt soaking, in addition to relieving the muscles, is that your body uses magnesium for a lot of different processes, including immune health, including things like, sorry, my brain just stopped for a quick second. Your body also uses them for, where did my brain go? It's gone, sorry. But the big thing is that with your body using that magnesium, part of the idea of the soak is that your body can just absorb that magnesium through your skin from the water. And again, like I said, we have no scientific definitive proof on that, but science is always changing. We're always learning new things. And so hopefully in the future, as more studies are done, we can learn more about that, and possibly we'll get some definitive evidence that will show us one way or another, once and for all, are Epsom salts helpful. What we can say for the fact is that soaking in a warm bath, just the water alone, actually does help to relax your muscles. It does help to reduce soreness, and it is a stress reliever. So whether or not you add Epsom salts is up to you, but just that warm water soak is helpful. So one of the things that you can do in class is you can have your students create their own Epsom salt soaks and then test out whether it keeps the bath water warmer for longer or whether it changes the consistency and the feel of the water. They can look at the difference between the volume of the water. If I add something to it, does volume increase? Does volume decrease? Does it stay the same? So to make this particular item for your classroom, what you're going to do is you're going to need some Epsom salts. You're going to need sea salt. You are going to need some essential oils, baking soda, and food coloring. Okay. All right. So let me zoom in so you can see what I'm doing a little bit better here. All right, so we're going to start by just mixing all of this together in some sort of a mason jar. Whatever kind of mason jar you have that you want to use is helpful for this. And we're going to start by adding 3 tablespoons of Epsom salt. So here's 1, 2, and 3. Okay. Then to the Epsom salt, we're going to add 2 tablespoons of sea salt. Maybe my sea salt's kind of stuck in the package. And this is a great activity to help kids learn how to measure things accurately. I'm not doing a real good job of being super accurate here. But in the classroom, you would want to have the students measure this over another container, level that off, and then pour it in to do accurate measurements. So there's my 2 tablespoons of sea salt. And then I'm going to add 1 tablespoon of baking soda. Then to all of this, just add as many drops of essential oil as you like. I typically try to stay between kind of 5 and 10 drops of essential oil. That was 7. And you can choose to add coloring or not. I'm going to add 2 drops of food coloring to this mixture. Then I'm going to put a lid on my container. And I'm just going to shake the container now. And as you continue to shake, what you'll find is that the ingredients all mix and the essential oils and the food coloring distribute evenly. It takes about a minute or so. And there you have it. So you can use this Epsom salt soak in your bath water, or you can also use this to do some experiments in class. And you can check and see, again, like I said, does the consistency of the water change? Does the volume of the water change? How does it feel? What happens to the color? Since you've added food coloring here, is the water going to change color? So you have a lot of options. And going back to the purpose of magnesium in the body, I'm sorry that I just had a moment there and couldn't remember what that was, but magnesium in the body is used to regulate blood pressure, it's used to regulate your blood sugar, it also helps to improve bone strength, and then like I said, it's also used in regulation of the immune system. So magnesium has a lot of great properties, but whether or not your body can actually absorb that magnesium by putting Epsom salts in your baths, we just don't know. Science will have to show us that in time. But that's the first bath product that we're going to talk about is the Epsom salts. Now, as we're going along in this live learn, if you have any questions, please don't hesitate to ask those in the comments on YouTube. I'm monitoring that on my computer over here off to the side, and I can see your comments as we go, and I would love to answer any questions that you might have. So just add those to the chat bar. If you're on your phone, the chat will be at the bottom of the screen. If you're on your computer, the chat's typically off to the right side, depending on the type of computer you're using. All right. So, moving on from the Epsom salts, we're going to go to our next favorite bath product, which is bubble bath, and that's what you see in this container here. And in a less than genius move today, let me slide out of the way, I made my bubble bath orange, and I wore an orange shirt, so a little camouflage action happening there. You can see that bubble bath. So why are we interested in bubble bath? And what's the chemistry behind bubble bath? Well, Bubble bath contains soap, and soap is a surfactant, surfactant, surfactant. And surfactants are any sort of chemical that reduces the surface tension on another liquid. So, for example, when you add soap to water, it reduces the surface tension of the water and makes that water able to mix with other things more efficiently. So if you're using a cleaning product, you can mix soap or any other surfactant. Soap's not the only surfactant, but you can mix a surfactant with that water and then add in your cleaner, and it actually makes the cleaner work better because it dissolves more readily in the water. Now, where else would we find surfactants other than cleaning products? Well, interestingly enough, your body, your lungs, actually make a pulmonary surfactant that we find in the alveoli. So your alveoli are the little kind of grape-looking clusters where the gas exchange actually occurs between the capillaries and the lungs themselves. And so this area goes from being a very liquid-rich environment in the capillaries to being a very dry environment in those tubes. And so the surfactant that's in your lungs actually surrounds those alveoli and those wet spaces. And its purpose is to help the lungs stretch when you inhale. It keeps your alveoli from collapsing when you exhale. And it also helps keep your airways dry and that liquid edge where the alveoli meet the capillaries from going up into the rest of the lungs. So the capillaries are sealed, but because the edge of the alveoli are wet, we don't want that moisture getting up into the lungs all the time. So the surfactant helps prevent that from happening. We also would find surfactants in places like car or motorcycle or lawnmower engines, places that we need to keep parts moving. And so we add surfactants to the lubricants and the oils that we put into our engines, and that prevents particles from sticking to the side of the engine and causing damage, and from from keeping the parts from getting stuck together so that they don't move. So it just basically keeps everything moving nice in your engine, and so you don't have any breakdowns on the road. So how do surfactants work? How do they reduce that surface tension with water? Well, if you've ever done the drop of water on the penny experiment, you know that you can fit quite a few drops of water on that penny because the water ends up creating a bubble on top of the penny, and that's due to the surface tension of water. Surfactants, on the other hand, are a little bit different. Surfactants are actually a lipid, and lipids are things like oils and fats. So, in this case, our surfactants look like a little circle, and that's the head, and then they have what we call a tail that comes off the end of the head. This little head is what we call hydrophilic. Hydro means water, and philia is the prefix for loving. So that means that these heads absolutely love to be near water. The tails, on the other hand, are hydrophobic. Hydrophobic means water hating or water fearing, phobia. Like if you have arachnophobia, you're afraid of spiders. So in this case, the little tails hate to be near water. If you think about it, it's kind of like when oil and water, they don't ever mix because those tails are that oily part that doesn't mix well with water. So when you have a surfactant, what you actually get are groups of these molecules all lining up side by side. And when you add water to that mix, only the round part of these surfactants is going to want to touch the water. So you have your little water molecules in here, which I'm going to use stars to represent water molecules. So the hydrophilic heads are touching the water and the tails are pointed away. If we continue to add surfactants, what ends up happening is that the surfactants group together in such a way that they sandwich the water between two layers of surfactants. This is actually something that we call a bilayer, or two layers. And this is how cell membranes work as well. They're using what are called phospholipids that have two tails instead of just the one that you'll see in most surfactants. So if we were to zoom in on, say, a bubble, we'll put a little bubble mark there for you. This section of that bubble would look like this. If we zoomed out, this whole entire bubble would be one giant round sandwich of these surfactant lipids with water in between the layers. So a bubble, if you were to zoom in, actually has a layer of surfactant, a layer of water, and then another layer of surfactant on the inside, and then on the very inside would be the air or whatever gas that bubble's collecting. So that's a little bit about surfactants and how those work. Now, the other question we get a lot, especially with bubble bath, is why are bubbles round? When you go outside and you blow a bubble, they're always round. When you do dishes and you have a little bubble that escapes, it's always round. Why is that? Why are bubbles always round? Well, it turns out that when a surfactant reduces the surface tension on water, that surfactant is looking to be as least stressed out as possible. So even though we've reduced the surface tension, we still can't stretch that water a lot. It can stretch a little more than it could before, but not a lot. If you want to prove how much that water can stretch, try the penny experiment that I previously talked about, and you do one experiment with just water drops on top of a penny and do another experiment where you're using soapy water, and you're going to get very, very different results. With the surfactant, because it wants to be as least stretched out as possible, it has to be contained in a small surface area. And if we go back to geometry, what we find is that the shape that has the least surface area of all is a sphere. So because of that property, bubbles are always going to be shaped into a sphere shape. The other thing that's kind of interesting with bubbles is that when you put bubbles on a surface, they actually form angles. And so you can see that on the screen right now. So these are bubbles that have been created, and they are sitting on a flat surface, and you can see that they're no longer round in shape. Most of these are pentagon shaped. This one here is kind of a strange looking hexagon, but wherever those bubbles meet, they form angles. So if you want to add a little math activity to your classroom, this could be an interesting idea to have the students measure angles or give them a challenge and tell them you want them to create something that has a 120-degree angle and see if they can blow bubbles onto a surface so that they create that angle. And this would be really easy to do if you had something like a clear protractor that you could set on the surface, kind of soap it, put some soapy water on it so the bubbles will stick, and then they can measure it that way, or they can just lay the protractor on the top, very carefully hold it above, and measure those angles that way as well. Another challenge that you might do with students is ask them to create a bubble that is cube-shaped. Now you can give them all sorts of different tools to try this, and you can do it a couple of different ways, but the easiest way is what I'm showing here on the screen, and that is by using a frame. And you can create the frame from just straws and string, or you can use a wire frame, just coat it, whatever you use, in some soapy water ahead of time so the bubbles will stick. And you're going to dip that frame into the water and pull it out. And you're going to see that the corners create an angle and it'll go all the way to the center. Then just take a straw and dip it in some soapy water, insert it into the center of the frame, and blow a bubble right in the center. And the bubble that you blow will be a cube shape. But I wouldn't tell your students this to start with. Give them just some materials and see if they can figure out how to create a cube-shaped bubble. Okay. So, how do we make a substance that we can use in the classroom to test about different bubble shapes and angles and surface tension on water? Well, the only way we can do these experiments is by creating a bubble solution. And so that's what I've created in the jar that I showed you earlier. And it's really quite simple. So to create this bubble solution, You're going to need a couple of things. Let me zoom in here so you can see them better. You are going to need some distilled water, and you can buy distilled water at the grocery store in gallon jugs if you don't have a distiller at your school. You want to make sure that this water is warm but not boiling, so about a minute in the microwave, it's just the perfect temperature. You're going to need liquid Castile soap, and you can buy that at the grocery store. This is unscented, and this came from the baby section of the grocery store. You can also buy this with different scents as well, and then you can leave out any scents from an essential oil if you want. You'll also need vegetable glycerin. And glycerin can sometimes be found in the grocery store. If you can't find it in your grocery store, cake decorating shops typically carry this. And then I ordered this one from online and got it in a couple of days, and you get quite a bit, and it was pretty low priced. If you're doing this as a spa product for a bubble bath, then again you'll need some essential oils, and you can add food coloring or not. That's up to you. So I'm going to zoom in to show you what I'm doing. If you do both of these experiments that we've done so far, the Epsom salts and then the bubble bath, this is a great chance to talk to students about the difference between measuring liquids and solids. So a lot of students think that the measurements for solids and liquids are interchangeable, and so that they could just do their liquids in just a solid measuring cup. But for accuracy, we want to use a liquid measuring cup for this. So it's a great chance for students to learn some life skills as well as science skills. You could also have them do this in a graduated cylinder, talk about learning to read the meniscus. This would be a great beginning of school activity. A lot of teachers do the penny drop activity at the very beginning of the school year, and you could combine that then with measuring in a graduated cylinder, measuring in a beaker, measuring in a flask, naming that equipment, and having them work through the process. All right, so to make our bubble solution, we're going to add a half cup of warm water. Zoom in just a little further so you can see that better. Okay. And then we're going to add in a half cup of our liquid soap. Again, this is a good reminder for students that they have to be down on the level of their measuring container to make sure that they get the most accurate measurements possible. We're going to pour that into the water. Then we're going to add 1/4 of a cup of glycerin. And glycerin can be a little messy, so just make sure you have some paper towels or cleaning wipes handy. All right, and then I'm just going to use a plastic spoon and give that a gentle stir until everything is mixed up. One of the things you could have students test at this point in the experiment is, does this mix better when it's warm or when there's cold water? You could have students mix quickly to see what happens, or have them mix it very, very slowly. All right, looks like everything's dissolved. Then I'm going to add my essential oils. I'm going to add about 10 drops. Ooh, that came out in more than drops. It's really quick. And then I'm going to add in a couple of drops of food coloring. Then again, I'm just going to stir really gently. And And then once I've stirred everything up, I can just pour this mixture into another container. All right, there's a little bit left over. And then I'll just cap off my container. Now you've made a lot more than you need for an experiment. If you're going to use this particular bubble bath recipe in a bath, you only need 1/8 of a cup for an entire bath. If you're going to use this in the classroom and you want to just make like a gallon of soapy water, you need about 1 tablespoon to 2 tablespoons depending on just how soapy you want that water. But there's lots of different experiments you can do with bubbles. The other thing that you can do that's really fun, especially for younger kids, is to see if they can put themselves in a bubble, and you can use a swimming pool with a hula hoop and have them stand on a brick in the middle, like a couple of bricks or like one of those big cinder blocks, and you can raise that bubble up over them. You can have them test how far a bubble will fly. Will small bubbles fly farther than bigger bubbles? So there's all sorts of different things that you can do with bubbles. If you attended our workshop earlier this year where Jennifer talked about cell membranes, this is a great solution to use for that as well. All right, let's check for questions. No questions yet. All right. So let me clear up a couple things real quick. When you do this experiment, if you want to talk about variables with your student, this is a great experiment to do that with as well. You could have your students adjust the amount of glycerin in the mixture to see if adding more or less glycerin changes the bubbles that are made. You could have students change the amount of soap to see if soap increases or decreases the size of the bubbles or the number of bubbles that are made. One of the claims that I actually found online that I thought was pretty interesting was about bubbles in a bubble bath, and that the claim is that having a bubble bath will actually keep the bath water warmer longer than not using bubbles. So that might be something fun that you could test in class, and just set up a couple of containers that have the warm water of the same temperature, add bubble bath to one and not to the other, and see if it really does keep the water warmer for longer. And of course, your students are going to be so creative with this. They're going to come up with all sorts of variables that we didn't even think about here. And so they'd be able to test all of those. And the nice thing is that other than not ingesting these products, it's okay to get them on your hands, and you can get a little messy with this. So it's really safe to do a lot of these experiments. Again, just don't drink the bubble bath because it does have soap and you don't want to drink the soap or the essential oils. All right, so that is all about bubble bath. All right, our last spa product that I'm going to talk about today are bath bombs. And you can see some different bath bombs in the picture here. We've made just some different color ones, but the recipes are all the same. So we're going to start out by actually making our bath bombs first. Right. So to make bath bombs, you're going to need a couple of different products. You're going to need a product called citric acid. And citric acid, let me zoom in on that for you so you can see it better. This is what the bottle looks like. You can buy citric acid at health food stores. They typically carry it. This particular bottle is a 1-pound bottle. They do make it, though, in much smaller quantities as well. But if you're doing this for a whole class, a 1-pound bottle should get you through quite a few students. You'll also need baking soda. You'll need cornstarch. You'll need oil of some sort. You can use vegetable oil, olive oil. I have just some sweet almond oil, so that's what I'm going to use. You'll need some water. You will need food coloring if that's something that you wish to use. And last but not least, you're going to want some sort of essential oil if you want your bath bombs to have a smell. All right, so making bath bombs is actually a two-step process, and it is a little bit of a challenging process. So just know in advance that if you do this with students, there may be some mistakes and they may have to start over. The humidity in the air can affect your bath bombs. So some days when it's more humid, you may need to use less liquid ingredients. If it's a drier day, you may have to use more of your liquid ingredients. The other thing is that if you add your ingredients together too quickly, you can cause the chemical reaction to take place, and then it will mess up your bath bomb. So just know that it does take, there is kind of a learning curve to this, but once you get really good at it, it's really fun to do, and it is something that students definitely could do in your classroom. All right, so let me finish moving my supplies out of the way. Let me grab my containers. Alrighty, so here we go. So there's two parts to making a bath bomb. The first part is that you want to add your dry ingredients in one container and your wet ingredients in a separate container. So what I'm going to add to my dry ingredient container is 1 1/3 tablespoon of citric acid. Let me slide this out of the way for you so you can see what I'm doing here. Again, this is a great chance for students to practice good measuring techniques. So we need 1 1/3 tablespoon. So that's half tablespoon. 1. And I don't have a 1/3 tablespoon measure, so that was about a 1/3. All right, then we're going to add 2 2/3 tablespoon of baking soda. So here's 1, 2, and that's about 2/3. Get my ingredients I don't need anymore out of the way. And then finally, you're going to add 2 tablespoons of cornstarch. And I'm going to use the back of a spoon to level this off. If you've ever used cornstarch, it comes out of the container in big blobs. So there's 1 and 2. Now I'm just going to use a clean spoon to mix these ingredients together. Okay. Ooh, a plastic spoon makes a squeaky sound in the bowl. Right. So once these ingredients are pretty well mixed, you can set this bowl to the side. And we're going to move on to our wet ingredients. So our wet ingredients, we're going to add 1 teaspoon of your oil, whatever kind of oil that you want to use. Again, like I said, I'm going to use sweet almond oil. So we're going to add 1 teaspoon of sweet almond oil. Okay. Then I need 1 teaspoon of water. Then I'm going to add 2 drops of food coloring. Grab a paper towel here real quick. So 1, 2. Oops, bumped my camera stand. It's moving around a little. And last but not least, I'm going to add 10 to 15 drops of the essential oil that I want to use. Before I do that, I do want to show you something that's happening in the container that's kind of interesting to talk about. You'll notice that the drops of food coloring are doing two different things. So the one in the bottom left really started to spread out almost the moment I dropped it, and the one on the right here, didn't so much. It's a great chance to talk again to students about how oils mix with oils and water-based liquids mix with water-based liquids, but oils and waters don't mix. And so food coloring, at least the kind of food coloring I'm using, is water-based. So we know that the one that's spreading out quickly must have been dropped in the water because it's diffusing very quickly, and the one on the right was dropped into the oil because it's keeping its shape and it's created what we would call a vacuole in there, and it's staying in a bubble shape. The other thing that you can talk about with students is diffusion. So let me zoom in a little bit more so you can see it better. But you can see that on one side, let me slide it over carefully, where we put the original drop of food coloring right here, it's very, very dense and very dark, and that means there's a lot of molecules that are in that particular spot. And as we spread across, you'll notice that over here we have very, very light area. And so this process is called diffusion, where molecules spread from an area of high concentration to an area of low concentration. So this is another chance to just pull in some more science terms and spiral that learning back to things that especially your older students, so middle school and high school, would have learned in class. All right, so let's zoom back out and let's add that essential oil. Five, 6, 7, 8, 9, 10. This is lavender, it's a little strong, so we're just going to add 10 drops. And then I'm going to use another clean spoon, and I'm just going to give this a mix. Now, of course, because we're mixing oil and water, it's not going to mix. So you can see all those little vacuole bubbles, let me slide it over here for you, that have been created by that water and that food coloring that have mixed, being surrounded by the oil that hasn't. This would be a great chance for students to add some of that bubble mixture to this, and they would be able to see how all of a sudden it would all mix because that surfactant would break the surface tension on the water, and that would allow the oil and the water to mix a little bit better. All right, so to create your bath bombs, you're going to start, and I would use a dropper in class for this, but you can have the students see what happens in this first just by creating a little well and then dropping a single drop of the liquid solution into the cornstarch and citric acid mixture, like so. And what we notice straight away is that there's a fizzing reaction. And so the question you can ask your students is, why is this fizzing? What's happening? Well, what's happening right now in our mixture is that you're having an acid-base reaction occur. So citric acid is a weak acid, and baking soda is actually a chemical called sodium bicarbonate, which is a very weak base. And so when they mix together, which is what we're seeing happening here, so we've added the liquid, which has caused both of those dry ingredients to become liquefied as well. And so they're mixing together, and we know that acids and bases, when mixed together, neutralize each other. And so we're seeing that a chemical called carbon dioxide, in this case the gaseous form, or a gas carbon dioxide, is being produced. And that gas carbon dioxide is then going from the base of the reaction up to the surface, and as it goes through those other liquids, especially the oil, it's getting caught, and that's what's creating those little bubbles. If you do the volcano reaction in your classroom with baking soda and vinegar, it's the exact same reaction. The difference here is that sometimes when we do the volcano reaction, students have a misconception that that's actually how volcanoes work, and it's not. So this is a much better way to demonstrate acid-base reactions for students, and it doesn't create any misconceptions on what's happening inside of a geologic feature, because you're seeing it happen in a bowl with specific chemicals. All right. The cornstarch that's in here doesn't actually have anything to do with the reaction itself. Rather, it's helping as a filler, and when we put the bath bomb into the water, that's when the cornstarch plays a role. So we'll see that in just a second. Okay. So let's finish our recipe. The reality is, when you're making a bath bomb, you actually don't want this to happen, or you want to limit that happening as little as possible. So as soon as you add the liquid, you actually want to mash down with the back of your spoon and try to force everything to mix quickly so that you don't get a big bubble. So we're just going to add our mixture very slowly, a few drops at a time. And when the bubbling starts, we're just going to use the back of our spoon, mash it down, and mix it as quickly as we possibly can. Let me zoom out so you can see that happening, how we're mixing. Okay. And again, I'm just going to add a little at a time. That's good. Kind of mash that reaction down and mix as quickly as possible. And depending on the kind of bath bombs you make, this is enough to make 1 or 2. So this is a good amount for a single student if you're doing this in class. All right, we're just going to go ahead and add the rest of that in there. Again, mix as quickly as you can. You can use your finger to kind of pull the extra off. If your mixture is a little dry, and mine is looking a little bit dry because I am in a very dry room today, what I can do is just add a little bit of water to it. And then continue to mix. Now you'll notice just the water created that reaction, and that could be another interesting question for your students to explore. Have them test the oil versus the water and see which one is actually causing the acid-base reaction to occur. All right, this isn't completely mixed together. You'd want to keep going until it's all mixed, but just for time's sake, I'm going to go ahead and move on. So at this point then, you want to put your bath bomb into some sort of a mold. And so you can have shapes like we've created here. So to mold my bath bomb, you have a couple of options that you could use. These are some of my favorites here. You can buy fancy bath bomb molds online, but they're expensive and you end up with the same results in the end. So you can just put your bath bombs down into ice cube trays. So you just take a little bit of that mixture, drop it into the ice cube tray, and then just use your finger to mash it down. I didn't do this just for time's sake, but it does help if you coat these with a little bit of oil before you mash the mixture in, just so that the mixture comes out easier. So that's one option that you can do. And when you remove the bath bomb from that ice cube tray, it'll look something like that. Okay. Another option that we could do is to use cookie cutters. They come in all sorts of different shapes and sizes. And so you just take your mixture and you just lay it into the cookie cutter. Use your fingers to mash it flat. You can fill up the entire cookie cutter with your mixture, like so. And then just carefully remove the mixture from the bottom of the cookie cutter, like so. Another option that you can use is you can take an Easter egg and put some oil on the inside of both sides of the Easter egg, fill those up, mash down with your fingers, and then squish it together and kind of twist and squish, and then you carefully remove each side. And I have half of a bath bomb done that way over here that I'll show you. So the bottom part I didn't do, I just used the top, but I molded this one with the top of an Easter egg. Okay. And then the other thing that we can do is you can just go really, really simple, get some of the mixture in your hands, and then just squeeze it. Now the way you know that you need more water is if it doesn't stay together when it's squeezed like this, or when you try to mold it, if it just immediately falls back apart, you need more water. Bath bombs have to dry before they can be used. You have two options to dry. You could just let them dry overnight out on the counter, just like we see them now. Or my favorite way to dry them is to heat up your oven to its lowest setting. I typically use somewhere between 170 and 200. My oven starts at 200, so I just turn it up there, let it get preheated, and then kind of turn it down to the warming feature. And then I put these just on a cookie tray and stick those in the oven and let them just dry in the oven for 45 minutes. If they're a little bit thicker, like these right here, that have been molded in the cookie cutter, sometimes I'll let them dry for about 30 minutes and then I'll flip them over and let them dry for another 30 minutes. Okay. So if you've never seen a bath bomb in person before and what that looks like, let me show you. Let me slide this example over here. Okay. And this can lead into another realm of inquiry. So here's one I made earlier today, and it's been dried in the oven, and we're just going to drop it into this water. And you'll notice that we immediately have that acid-base reaction start to occur as the baking soda and the citric acid comes into contact with the water. They become liquefied and they mix together. And then all these bubbles that are forming at the top are carbon dioxide bubbles. If you want to turn this into an inquiry experiment for your students, what you could do is have your students adjust the amounts of the different ingredients that they use. So does changing the amount of citric acid affect the bath bomb and how many bubbles it produces? Does changing the amount of water that you've added in the process change how the bath bomb works? Does the freshness of the bath bomb, if I drop this new bath bomb into water, is that different than dropping the dry one into water? Does the surface area change? So if I use the bigger flour versus the smaller flour, does that change how quickly the bath bomb dissolves? Or you could take one that's already done and drop the whole thing in, take another one of the same size, break it up into smaller pieces, and drop that in and see how that changes the rate of the reaction. The other thing you can do is you could substitute another acid. So you could use something like cream of tartar or lemon juice in place of the citric acid and have your students experiment with that. Again, like the bubble recipe, all of the ingredients we're using are safe for students to touch and handle. So you can do a lot of chemistry experiments without worrying about your students getting an acid on their hands that's going to cause damage to them or sting or burn them or, eat holes through clothing, things like that. So lots of different experiments that kids could do with these ingredients and with these particular items. The other thing is they make great gifts. So you can have your students do these experiments in class and then on the last day make a couple, and they would be a great Mother's Day gift for students to give away. All right. So that's all of the different science pieces that I have about our different spa products. So the science behind Epsom salts, what we know, what we don't know, and the research that still needs to be done there. All about bubbles and how surfactants work. And finally, all about bath bombs and how acid-base reactions occur. So I hope you've enjoyed watching today. Again, if you have any questions, don't hesitate to ask those in the chat, or you can email us at teacherworkshops@perotmuseum.org. If you still need credit for your STEM Teacher Institute this year, then please check out the survey link. It's at the bottom of the screen in the show notes description. You can just click on that Survey Monkey, complete your reflection, and you'll get your 2 CPE hours for this particular webinar. If you have any questions about that, again, don't hesitate to email us. Thank you so much for joining us today, and we look forward to seeing you next time. Thanks so much and have a great day.